as you can see in array nums, and an integer k, you have to return the number of subarrays of nums. Again, you know, every array has roughly n square number of subarrays. Now, when I say subarray, it can be 1, this, this. Next subarray can be this, this. Next subarray can be this. So you saw that I have 6 subarrays for it. Now, I have to return the count of those subarrays where the bitwise AND of the elements of the subarray is equal to k. Now you can simply see that in the answer I have to return a long. Why is that the case? Because number of the subarrays can be roughly, as I told you, n square, which is n into n minus 1 by 2. In that case, or I should say n into n plus 1 by 2, in that case, you saw that n into n plus 1 by 2 can be equal to more than int. That is the reason they have put a long. You can also put a long, that will also work. Now coming on back, how should we solve it? Now a simple brute force approach says the same way I find subarrays, the way I find the subarrays, let's generate the subarrays and then take the AND of them and then get the answer. So very basic brute force space is generate all the n square subarrays. For those subarrays, take the AND of that specific subarray at max can be of length n. It will take O of n cube time. But these kind of brute force approaches we have already seen there is a way to optimize it. While generating these subarrays itself, go and find the AND so that this extra operation of n time will not be there. Thus, what I can do, okay, let's say I'm at this index. So I'll take a subarray, all the subarrays up till this point. Okay, only one. So far the AND operation is 1. It is matching. Again, I have to tell all these all such number of ANDs ending at this specific index I. Okay, I have only one. I have only one, which is one of the AND. Okay, I'm good. Answer so far is 1. Now my I goes here. All these subarrays ending at index I. So one such subarray is this, one such subarray is this. Both way how I can generate it in O of n time only, that if I'm at this index I will go on backwards. Okay, so far the AND is 1. Again, AND is 1. You can keep on going backwards just as you can see, so far the AND value is 1. Again, if you want to incorporate the next element, take this element and will again become 1. So far it is 1. Then when the next element comes in, again do AND with the resultant value. So you can simply, while generating the subarray itself, you can also compute AND value simultaneously. And thus, as you can see, when I was doing here 1, okay, increase the answer by 1. When it also came in, again the AND value is still 1, again increase the answer by 1. Thus you saw that my answer is 1. Okay, great. Now the I shifts, I is here 1. Okay, then the AND value increased again 1, increase again 1. So it is 1. So again 1 plus 1 plus 1, which is 6. So you realize answer is 6. But now you will say, Aryan, this is O of n square. This will for sure not work. Obviously, this will not work. But do you remember one very important fact which we had discussed twice? That AND value is something which always decreases. Yeah, Aryan, that makes sense. That yeah, it always decreases. What I can infer from it, I can simply say that if I was at this index, my AND value was 1. Now, when I am now at this index, let's imagine what all distinct AND values I had previously. In this case, I had only one of the AND values, which is 1. I will firstly incorporate I. Remember, मकसद नहीं बोलना. Your main aim was for a specific index I ending at that index. How many such AND values are there which are equal to k? Separating, like forget about the equal to part, like equal to k part. Just see what all AND values I can generate, which all of them end at index I. So I'm saying that so far up till this index, I had get me all the AND values. I will do AND with nums of I, then I will get all the AND values ending at nums of I. But these are all the AND values which are previously and then impacted by nums of I. There is still one new AND value which is nums of I itself. So ultimately, what will happen at this point of time when my I is here? So far, the and values distinct and values over one. When I came in, one will be there, and also one itself is there. So again, number of distinct and values are still one. Forget about the answer, computing the answer, but just see number of distinct and values are one. Okay, next time next time one came in, so 1 and 2 value is 0, 1 and 2 value is 0 again. So number of distinct and values ending at this index I are, one of the and value is 0, another and value will be 2, and another and value will be 2. These are the only two distinct and values, but you diverted from your aim. You're again like not diverted, but like you just found a problem, a sub problem part roughly, that okay, Aryan, this seems okay, this seems great, and I also see that if I will keep track of distinct and values, these will be less right now, because I can see that it is repeating, so it will be less. Okay, now your main aim was to actually find the count of subarrays whose and value matches with k. So I have to also maintain the count. So you realize one thing. One thing I want is distinct and values at a specific index, and I also want the count. Whenever the count comes in picture, we always know that we take a use of a map. And because of we have to keep track of distinct, I can simply take a map will help me work both of them. Okay, I can take a map here itself. So what happens at this point of time, I will find distinct and values, and I will also keep track of count of those and values. So I will say map of 1 is the and value, and the count so far is 1. Now, next time when I'm trying to compute the and number of distinct and values ending at index I will take all the previous different and values, which are the keys of my map, and then I will do and. So 1 and 1, I'll get a 1. So, and again, I have only one distinct and value, which is 1 only. So I will ask you, now what is the count? Count is still a 1 because of the impact of previous and value. Doing and with I nums, which means 1 and 1, which will give me 1. So this will say this is the current one and this is the previous one. Count is same as this count, 1. Okay, if that is the case, okay, which means now so far I've incorporated 1 and 1, but still at index I will have again 1. So map of 1 only will be also increased. So far with this, map of 1 has become 2. Again, I will add that 2 in my answer. So far in my answer, I have added 1 and I have added 2. So far answer has been 3. Now when 2 will come in picture, you will realize that map of again distinct and values I have so far is only 1, which is 1. So I'll do 2 and 1. Count will be 2, and I will do count of and value of 2 will be only 1 because I have 2 also. I have to also take that in consideration when my index I is here. This will tell me that my count of and values of 0 ending at this index will be 2. Count of and value of 2 ending at this index will be 1. Here, none of them is actually a 1, so no answer impacted. Thus, the total answer is 3. Now, for the folks who agreed from me, you need to ask question to like YouTubers. This is something I just taught you. This is something not resolving your answer, and this is something you would have never reached on from your end also. This is just simply a statement. How to reach it is, how to reach to this point was, again, this is the actual answer. This will work, but there are many questions how you came to it and how you actually will prove that this will work in the complexity. Now let's see. So far you realize one thing, that what we were trying earlier, we were trying to find all the subarrays. It is the same point from where I left it with example 1. Let's repeat the same point. So and values will be 1, and values ending at this index 2 will be 2, and then 2 and 1, 2 and 1. So 2 and 1. And values ending at index 3 will be 3, 2 and 3, and 0 and 3, because this portion I have already computed, so why not take leverage of this portion? Okay, Aryan, oh, by this example, it seems like it matches with what you have done earlier. You are using existing value, but 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 my question is, will the complexity still not be same? Which means that you are incorporating x4, and then with x4 you will take all the and values previously you had. Please shant ho ja. All the and values you had previously, you will take all those and values again, all the distinct and values you had previously, you will do and with x4, and these are all the remaining values, and then I have x4 here. So your question will be, Aryan, this is for a specific index I. What if these are n distinct and if these are n distinct and values, if I do a and with x4 and done, it will be again O of n square. Yeah, you are correct. So I will ask you to pause right here and tell me, will these be n distinct and values, or will it be constrained with some specific example? And again, a big hint for you is that and value always decreases. Now for the folks who thought of by this hint, good for you. You can just write the code itself because the problem is done now. For the folks who could not think of, I taught you again and again the same thing, and value always decreases. Take leverage of this portion. Now, because of that thing, my claim is distinct number of and values previously can be 32 only. And thus, if I will take the and with x4, I will have x4 and 32 and values, but in out of them, distinct and values will again be at max 32. Again, this 32 will go to x5, so I will have x5 and 32 and values. Distinct number of and values will again be 32, at max 32. Now why is that? The claim is for any specific value xi, let's imagine that I had previously, again I'm just trying to show you, let's imagine I had previously 50, or let's say 100 previous values. Now, technically your task was xi, xi and this value, xi and this value, xi and this, xi and this, and like entire portion, you are always taking the entire portion. So this is what you were doing. This is what you were doing. Now, as xi is a 32-bit integer, because you see xi value as an nums of I, it is 1e9 at max, which means it can come in integers limit, which is 32-bit integer. In that case, the max to max value, again I'm exaggerating, 2 raised by 30, 31 is actually 2 raised by 31 is actually lesser than 1e9, but still, if even if I exaggerate and take a little higher value, max to max I could have 32 bits as set. If all the bits are as set, and I told you, you want to grab distinct and values, you have to grab distinct and values. If I have this value, if you want, again, if this value is all ones, you want some different and value, again as soon as this element, let's say xj, came in, you want some different, and value. So for sure you don't want it to be xi, you want it to be different from xi. How this can be different from xi? Considering I will make one of them as 0. Okay, then I got my xi and xj, which is this value. Now as soon as xk will come in, again and value, which should again decrease, which means this value only should only decrease, which means how I will decrease it, or how, again I have to decrease it, or I can make it remain same. If I make it remain same, distinct value count will never increase. Now to make the distinct and value count increase, I have to make it different. If I make it different, I have to change some of the ones to 0, because it is and always decreases. I can only decrease it, I can only make 1 to a 0. I'll again decrease it. So you see that as I keep on moving so as to get different and value every time, I will have to every time make one of the ones to a 0. And as it is a 32-bit integer, I can have at max 32-bit. I can have 32 bits as set, which means I can 32 times make it a 0, which means that I can have at max 32 distinct AND values at any point of time. So that will help me, because if I have 32 AND values in previously, then I will do it with x4 or let's say x5. I will again get 32 AND values and then x5 as a new value again, but still it will ultimately have 32 distinct AND values only. And thus, that is the reason at every index, I will go and look for this set of distinct AND values, whichever I have, and I will take my x of 5 or x of I as a person and do a AND with the previous set, because I want to know all the AND values ending at this index I. Now, I could have taken a simple set, but I will take a map because I want the count also. As we discussed here, we want the count also. And thus, this is how we leverage AND property and how we leverage that using my existing bit value, as in like I can have at max 32 bits. Thus, I can make my bits 0 only and only once, and this answer to always keep on decreasing. Now, a few people will simply have a doubt, Aryan, but if you have a bit as 1 and 132 times, you can make something as a 0, then obviously you can make it 0, then make this 0, then make other one as 1, and then make other one as 0. So you will have 32 combinations. That is the issue that you did not understand properly. If I have a 1, I'm doing an xj and xi, which will reduce. Let's say this is 1, which is xi. If I do xj and xi, so let's say I reduce from the bits to 0. Best case scenario. Other one should be in the existing xj and xi. In the existing xj and xi, I have to make sure I have to again reduce something in the existing value only. So in the existing value, I will only have to keep on reducing and reducing and reducing. And that's the only crux and intuition. Now, let's come to the code. It's exactly same as what we discussed, that we will first take n and my answer. My answer should be long, right? Now I will take previous and count. This is a map which tells me that distinct and values previously in the previous index. Because this I will take in consideration at the current index I will take all different previous and values to check the new AND values, and I will copy over the count as it is. I will copy over the count as it is. So this is the nums of, this is the nums of I, and these are the previous distinct AND values which will come from my map. So this is for that my previous distinct AND values. Now I will iterate on all the nums. That is what I was doing, going in order. I will make my current and count, which is this current map. I will make my current map, and I will take leverage of my previous map to generate my current map. To generate the current map, one thing is I will take nums of I, do a AND operation with all the keys of my previous map, and one thing will always be extra, which is nums of I itself. But remember, still, distinct number of keys will never exceed 32. Okay, so I will take my current AND count, which will contain the current map. I will iterate on the entire previous map, which is the previous AND value. I will do a AND with the current nums of I, and thus I will say that this is the new count for that specific new AND value. Right? I'm just simply adding. I'm as you can simply see, I'm just simply having let's say nums of 0. I just added a 2. I just added a 2. And why did you add a 2 and why did you not simply assign a 2? Because let's say if map of a 3 would have been a 2 here also. And here, because of again, let's say not map of 3, let's say a map of 4. Map of 4 would have been a 2. Now, because of this map of 4, in the previous section, when the map of 1 and map of 4 both are there, map of 1 and 2 gave me map of 0. Same way, map of 2 and 4 will again give me a map of 0. So count of and value finally as 0 will be 2, existing value 2 plus 2. So I should always keep on adding. So I will always keep on adding my count. And also when this portion is done, make sure that nums of I will always have its distinct count ending at that index I. So always make sure that current and count of nums of I should also be increased by 1. Now when this portion is done, your task was your task was to find number of subarrays ending at that index I whose AND value is equal to k. So iterate on your current AND count, check all the AND values equal to k and increase your count ending at that specific index, which is nums of I. Increase the count to the specific count and ultimately return your answer. Make sure to assign your assign your current AND value to your previous AND value, because you are simply keeping on forward. Now because of this previous AND count can contain distinct 32 values, so this map size will at max exceed 32, and your n is n, nums of I like indexes are n indexes, so your time will be 32 into n. Because you're only using your previous count and current AND count, which is our two maps, both having a size of at max 32, your space will be 32 into 2, and that is your most optimized time and space complexity. Cool. This was easy just because of one fact, because you are exactly comparing it to equal to. The only thing which made this problem easy, or I should say medium, was it is exactly comparing to equal to. If it would have been closest, then you would have to apply a binary search or maybe something like sliding window just so as to get to a closest value. Cool. I hope you got it. If yes, then do smash like baby to let me know how was the audio. And yeah, see you. Goodbye. Take care. Bye bye. And do join Discord and on LinkedIn.